If you have zero experience in making games, then today you will learn quite a lot of new stuff. I might make separate tutorials on each topic in the future, so make sure to like the video if you want to see that. But for now, if you see any material that you are struggling to understand, practice it and also ask AI for help and better explanations. The other option is to comment down below and I'll make sure to reply in more details. Let's begin. We are going to be working with Godot Engine. It's a very small but also very powerful engine, and even if you have a potato computer, it will still run smoothly. Well, hopefully. If you don't have Godot already installed, then search for it, download it, and just unzip it in some folder, and you're ready to use it. As you can see, the process is very simple and the engine takes almost no space on your disk. Open up a brand new Godot project and create a new Node 2D scene. A scene? What is a scene? You can imagine each scene as a container that holds things. Example, a game level scene that contains all things and assets in the current level. You can imagine rocks and grass and all entities in your world added inside of that scene, of that container. This is literally what our main scene will be. It will hold everything and it will run when the game is launched. Another example, a player character scene that contains the texture of the player, the animations it has, and the custom logic that is attached for movement. So in this case, instead of a full game level, you can imagine just a single character that can be controlled and moved with the keyboard and mouse. Only that. There are no rocks here and no grass. The player is a separate entity and only when it's finished we add it to the game level scene where it can interact with the rest of the level. Seems quite logical, right? So, let me test you if you understand the concept of scenes. What would an enemy scene be then? What should this container hold? If you truly understood the concept of scenes, then your answer would be something like, an enemy scene is a container that holds all things related to an enemy. An enemy has a texture because we want to see it. An enemy also has its own movement behavior because it can detect the player and try to damage him. An enemy could possess different abilities or have animations just like our player can. Do you now get it? All these things that the enemy should possess are grouped in a single scene that makes up our enemy. All the things that makes the player an actual player are also grouped together in their own scene. And then finally, from all our custom-made scenes, we group all of them together and that makes our main scene that can be played. This makes up our game. When you really think about it and imagine all of them as just containers of logic, it's pretty simple. Double-click on the parent node and name it main. This scene will act as our level scene. It's the main scene that will contain everything. Click on the play button and then when you're asked to select a main scene, click on select current button. Save the scene as main.tscn. Now that we reach this point, each time we press the play button, we'll see the empty grayish screen. Let's implement the player. Okay, so we know what scenes are, right? But how do we implement the behaviors I told you about? A scene having a texture, a scene having some logic. How is that done when we just have an empty scene right now? Well, a single scene consists of nodes. Godot has many different types of nodes and we'll take a look at some of them. Each node has a different purpose. You might have a node for displaying a simple 2D texture, or you might have a node that is responsible for rendering particles. Add a child node and select Character Body 2D. From the description, you can see exactly why we chose this node. We can control it, move it around, and it provides some very useful functionality for us. Double-click it and rename it to Player. Right now, our main scene contains this Player node, but we want to turn this Player node into a separate scene that would contain many other things. Just remember, the rule is, if it's a different entity, put it into a scene, and if it's something complex with its own logic and code, then again, put it into a scene. That's all. Go ahead and make a brand new folder and name it Player. Go on top of the Player Character Body 2D node and right-click, press Save Branches Scene, name the scene Player, and put it inside the player folder we just made. Now, each time we want to modify the player, we're going to be clicking this Open in Editor button. This button will open up our player scene. After clicking it, you'll see that we now have two tabs open. First one is for our main level that will contain all entities including our player, and the second tab is the actual player scene that we are going to be modifying right now. It's time to add some textures. Well, since this is a very basic tutorial, I would like you to open up Paint for a bit. I know. If you have a better image editing program, open that instead. We are going to create two very simple assets, a square and a rectangle. Make the square's size 64 by 64 in pixels and make the rectangle 120 by 32 in pixels. They both should be filled completely with white. Go back to your Godot project and make a new folder and call it Assets. Right-click on it and then click on Open in File Manager. Now cut and paste both assets inside. Again, we are doing this as practice, but when making your final game, you will make better assets by drawing them or hiring someone to draw them for you, or maybe finding free ones online. Right now, we are just dealing with this as beginners and focusing only on the actual game engine. Go inside the player scene and right-click on the parent node. Then add a new child node, search for and select Sprite 2D. Click on the Sprite 2D and on the right side of the screen you will see the inspector window. Next to texture, click on the empty field and then click on Load. Now, go to the Assets folder and select the square.png asset you made. To move around the screen, you can select the hand icon at the top and drag across the screen, or just press space and drag. You can also use your mouse scroll wheels to zoom in and zoom out to a specific location where your mouse is pointing. We see the white square, but I would like to turn it blue instead. So click on the Sprite 2D node and go to the inspector again. But this time expand the visibility drop-down and click on Self-Modulate, then choose a blue color. Make sure you save the changes by holding Ctrl and pressing the S key. If we go back to the main scene tab, you will see that it has been updated. The player has really become a blue square. If we click on the play button, we are gonna see it at the top left corner of the screen. Let's just select it and drag it somewhere in the center so that we can view it better. Let's go back to the player scene. First, click on the player node and press the Attach Script button. You will see that by default, Godot names it the same as your node name and also wants to place it in the same folder where your scene is located. This is exactly why we separate things by folders, so that everything stays nice and clean and you know exactly where your scripts and scenes are located without being confused. Click on the Create button. Now you will instantly see a brand new window. This is the script window. If you go at the very top of your screen, you will see that you can always navigate to different windows without any problems. You have the 2D window, the 3D window, the game window, and the asset library window. Let's go back to the scripts window. At the left side of the window, we can see that the player.gd is in bluish hue. The bluish color signifies that this is the current script that we're editing right now. If we had other scripts open, we could easily switch between them by clicking on their name. By holding the Ctrl key and scrolling up and down with our mouse, we can zoom in and out, which will decrease the text size of the window. Remember that a single node can have only one script attached. So, if a scene contains many nodes, each one of them can contain a script. Usually though, you will always attach the script to the parent node and place the most important logic there. Now that we have a script, let's write our first code. We would like to print in the console a simple hello world. How can we do this? We need to implement the ready function. I know if you don't know what a function is, then no worries, I'll explain briefly. A function is simply a block of code that has a name, and we can execute this block of code whenever we want. Godot provides some special functions that are executed at a particular time. We would like to print hello world as soon as the player is added to the scene and is loaded completely. Well, that's exactly what the ready function does. It allows us to execute logic when the node is ready. The name matches perfectly its use case. The keyword func is what signifies that we are writing a function. The ready is the name of the function. The brackets are for function arguments if the function needs them, and the arrow shows the return type. Since it points to void, it means that the function does not return anything. If you did not understand even a single thing here, then no worries, I will explain in a bit. Right now, we want to just print something in the console at the bottom though, so just type print and add the brackets. Now inside do single quotes or double quotes. No matter which type of quotes you choose from, it does not matter. Inside of them type hello world. Please make sure that you've added tabs at the beginning. Each line of code inside of a function should begin with a single tab. Now run the game by pressing the play button. At the bottom, inside the console, in the editor, you will see the text hello world. Can you modify this so that it prints hello in uppercase? If you know how to do it, then congrats, you now know how to print things in the console, the most basic thing that will help you a lot in the journey of writing code. Now that we know how to print things, let's talk about variables and types. As you saw, in order to print text, we had to put the text between quotes. This is called a string, and it's how text is represented in code. Let's talk about another concept that is again extremely important. Variables. A variable can hold a certain type of data. For example, we might have a variable that holds our hello text, or we might have a variable that holds a number. Let's test that out. In order to initialize a variable, we need to type the keyword var. And after that, we need to name it. I'll name my variable myText. After that, we type the equal sign, and then, as we said, text is represented in quotes. So type some quotes and inside type the word hello. Congrats, you now have a variable that holds a string. Let's switch the text inside the print statement and instead print the variable. As you can see, the print function printed the text that is saved inside the variable. If we change the variable value to something else that is not hello, then it would still work. Variables can have type hinting, which shows what is the data type that the variable should hold. Right now, we are holding text, so it's good to type :string after the name of the variable. This signifies that the variable can only hold a single string inside of it. Now, if we set the variable to a number and don't put any quotes, we will get an error, since this is not an actual string. If we didn't have the type hint, then we might face some issues in the future and hard to spot bugs since we could be switching data types from strings to integer numbers. This might be bad, so always use type hinting. If we want to store whole numbers inside the variable, then we use the int type hint. If we want to store floating point numbers, then we use float. Note that there are also other types that Godot has, but we will talk about them in a bit. This is the basics. Now let's talk about functions. We define brand new functions when we want to reuse code logic by grouping it together and calling it in any place that is needed. For example, if we had 10 print statements that say hello, we could group it together in a function and just call it whenever we want. I know this sounds kind of pointless right now, but it will really give you a great example. The whole point of functions is to reuse code. So let's do this. To define a function, we type func followed by the function name. In this case, I will name it say hello. After that, we need to add the brackets, and finally, let's provide a return type just like how we did with ready. I still haven't explained what this void does, but I'll give you an example later. Just trust me for now. Move these 10 print statements to a brand new function by copy pasting them. In order for you to not get an error, you need to type pass inside the ready function, which will tell Godot, hey, this function is actually empty, so ignore it. Right now, if we run our project, we will see that nothing is getting printed. Why is that? Well, because the ready function doesn't hold anything and is empty, obviously. So how do we call our custom function so that the block of code inside of it can get executed? Well, we just type the name of our function and the brackets and we are completely done. Now, if we run the project, we will see that all those print statements get executed. Pretty cool, I know. And guess what? If we call our function a second time, then we will get 10 more hello printed in the console, because we are calling that block of code 2 times. It's basically the same as copy-pasting the code we have inside of there 2 times. Functions make our code flexible and reusable. Now you might ask yourself, okay, but why do I need the brackets there? You can pass arguments to the function. This might confuse you a bit, but basically your function can expect some data being passed to it and then it can manipulate that data or just print it. To do that, let's modify the function by putting a parameter in the function declaration called text-to-print. Let's also add a type hint to signify that we want to pass an actual string. Notice that for parameters, we don't type the var keyword in front. Now that we have the parameter there, you will see that the call to our function is marked as an error. That's because in the brackets, we need to give a string value argument to the text-to-print parameter. So let's just type hello in quotes there. Since it expects a string and strings should be in quotes as we learned. Now, if we modify the function so that it prints the actual argument using the print statement and then run our game, we will see that the console prints the correct thing. Cool, so we learned how to pass arguments to a function. If we want more arguments to be passed, then we need to define more parameters with commas. Now that we understand function arguments, let's go ahead and understand what this void thing over here is. Simply put, this is the return type of the function. Now wait, you might think, hey, but isn't the function returning the result from the print statement? After all, we see the text in the console, so why are we setting it as void? What does this mean? Shouldn't it be string since we are printing? If you think like this, then you're a bit confused. It's true that we are printing stuff to the console, but that is not what the return type does. The return type is used when we expect the function to do some sort of calculation from the arguments and then return a result that we can then save to a variable and modify. Let's make a quick function that sums two numbers and returns their result. Func sum numbers, and we're going to add two integers as parameter values. Num1 is the first parameter, and the second parameter is num2. We also use type hinting to signify that we're dealing with two integer numbers. Now, as a return value, instead of saying void, we are going to say int2, because what we want to do is sum these two values and return an integer value. So let's type the return statement and then add the num1 and num2 values together. Now, when we call the function inside ready, we can save the result that it returns to a variable. Because the function returns an integer, we also need to save it to an integer variable. And now we just print the value of the variable. It's not even mandatory to use a variable. We can call the print function and execute our custom function inside, which will return the calculated value in place. That's what the return statement is, when a function returns some sort of calculated result. Nothing stops us from returning string or other types though, so functions are indeed very flexible. Congrats, you now know everything you need about functions. Now let's talk a little about how Godot works in 2D. If you've studied maths, you've probably seen the coordinate system at one point. Well, here in 2D, the y direction is actually inverted. So positive y is actually downwards and negative y is upwards. Let me prove this to you. Select the player node, go inside the inspector and look for the transform dropdown. You are going to see some properties there. The transform contains the following: position, rotation, scale, and skew. What we would like is to edit the position of the node so that it goes up. Normally, we would place a positive y value. So let's test what happens. As you can see, instead of the node being moved up, it went downwards. So just remember that anytime you're working with 2D, the y is inverted. Cool, so let's go inside our script again and write some logic that would begin moving our character in the positive x direction. We will write it in the ready function just to test what happens. Since we are interested in the position property, we type position.x plus equals to 500. Now there are some things to explain here as well. First of all, position is a property. But why are we using the dot syntax here and accessing the x? How does this work? What data type is position so that we can do that? The position property is of type vector2. This means that it has both an x and a y value. Sometimes when we are not sure about the type of a certain property, we can just hover over it with the mouse and it will display the exact type. Anyways, and what does plus equals to mean? This is just a shorthand of the following. Position.x equals to position.x plus 500. So, whether you type it this way or that way, it doesn't really matter. Now run the game and you will see that our player actually moved to the right of the screen by 500 pixels. Pretty cool, but this is not really movement, is it? We need a Godot-specific function that will allow us to execute this same code over and over again so that the player moves little by little each frame. This is what movement is. Well, luckily for us, Godot provides two such functions. One is called process and the other one is called physics process. They both allow us to execute logic repeatedly. The only difference is that process executes the logic as many times as possible in a second, while the physics process executes the logic by default 60 times per second. Why 60 times? Because, as the name suggests, the physics process function is tied to the physics engine. It is made so that all physics-related movements that have collisions can be handled correctly and detected correctly. So, anytime you're dealing with physics movements where a player needs to collide with something, then always use the physics process. If instead you have simple animations like animated textures or something, then you can just go ahead and use the process function, since everything will look as smooth as possible. Now that we got that out of the way, we are gonna choose to use the physics process function, since later we will add collisions to our player so that he can interact with the level. Inside the physics process, let's write the exact same logic, but instead of having the value 500, let's have the value 5. When we run the project, we can see that we successfully made our player move, which is fantastic. One very important thing here is that we should always multiply by delta, so let's increase the value to be 50. This will ensure that the movement behavior is the same no matter how powerful the machine of the user is, and no matter if there is a lag and frame drops. The movement will be consistent without any teleporting. I'll probably explain this in more details in another video, but for now just remember that if you have any type of movement, always multiply by delta for consistent behavior.